Welcome to the first video of section 3.1, and here we're actually going to get into what are called functions. And this, just like always, or so far what we've looked at, should still be review, but it seems to be a problem that many students seem to want to forget. Now, the first thing that we need to do is to determine whether or not a particular relation is actually a function, and if it is, then we need to state both its domain and its range. And the thing we need to remember here is that in order for something to be a function, every time we input a value, we get one and only one output value. Now, that doesn't mean the output values have to be unique, but the things we put in have to be unique. And so if we look at number 1, it has Alice going to cat, it has Brad going to dog, and it has Carl going to dog. Now, just because Brad and Carl both go to dog, that's not a problem, because every time we see Alice, it goes to cat, it never goes to dog. Brad always goes to dog, never goes to cat, and Carl goes to dog, never goes to cat. And so, yes, number 1 is a function. Then the domain just simply becomes what are the inputs, and so that would be Alice, Brad, and Carl. We show that with capital D. And the range, capital R, would be the outputs, and that would be a cat and a dog. And there is the answer to number 1. Now, number 2, once again, we have to look. We get 2.99. Whenever we put that in, we get 8.29. 2.999 gives us negative 8.3. 5/3 gives us 0, and 1.67 gives us negative 2. Nowhere in there do we have a duplicate input. And so, yes, this is a function as well. And so the domain would be the first numbers, and we want to put those in numerical order. So that'd be 1.67, 5/3, 2.99, and 2.999. That's the domain. And the range in numerical order would be negative 8.3, negative 2, 0, and 8.29. And there is the range for that particular function. Now, whenever we have functions given to us as a function, an equation, then what we do is, all we need to do is we need to look at, is anything special going on with y? For example, is it absolute value of y? Is it y squared? Actually, the things that we really need to be concerned with is y, does y have an absolute value around it, or does y have an even power? Those are the two big things as to what will throw a function out. So if we look at number 3, y equals absolute value of x. The absolute value of x is perfectly fine. So yes, that is a function. Number 4, y squared plus x equals 9. Well, y is being squared. It has an even power, so no, it is not a function. And example number 5, x minus 4y equals 8. Once again, the y has a coefficient of 4, but that doesn't throw it out. It has to have an even power or an absolute value. And so, yes, this would be a function. Now we're ready for example number 6. And in fact, this next group says find the value. Well, we need to remember that whenever we have f of negative 9, this does not mean take f times negative 9. This is function value, which says wherever we see the variable of the function f, we're going to put in negative 9. So in this case, we are going to take the absolute value of negative 9 minus 6. Absolute value of negative 9 is 9. 9 minus 6 is 3. And so f of negative 9 equals 3. Number 7, we are asked to find f or negative f of x. Well, since f of x is 2x squared minus 3x plus 4, we just have to negate everything. So that becomes negative 2x squared plus 3x minus 4. Number 8, we are asked to find f of 2x. Well, this means wherever we see x, we're going to put in the value of 2x. And this will take a little bit longer, but we have 3x squared. Well, instead of x, we put in 2x. So 2x squared minus 2 times 2x plus 3. Okay, this will equal 3 times 4x squared minus 4x plus 3. And one final step, multiply there, you get 12x squared minus 4x plus 3. And there is the final answer. We're now ready for example number 9. Nine and 10, we're just basically asked to solve the problem, so we need to go ahead and read it. We are told that f of x is equal to x minus 3a all over 6x plus 1. And we're also told that f of 6 equals negative 9. And we're asked what is the value of a. Well, this is pretty simple. F of 6 means we can put in 6 in for x. We know this whole thing's going to equal negative 9. So we get negative 9 equals 6 minus 3a over 6 times 6 plus 1. So negative 9 equals 6 minus 3a all over 36 plus 1 is 37. Multiply both sides by 37 and we get 6 minus 3a equals negative 333. Subtract 6 from both sides, negative 3a equals negative 339, and divide both sides by negative 3 so that a equals a positive 113. Example number 10. The function p of d equals 1 plus d over 33. Gives the pressure P in atmospheres at a depth d feet in the sea. Find the pressure at 41 feet. Well, this is pretty simple. All we have to do is find P of 41, which is 1 plus 41 over 33, which is 74/33. 74/33 what? Atmospheres, and we are told atmospheres are abbreviated as ATM. Now, in order to find the domain of functions, what we need to do is we need to determine where is it not defined. Now, some of the things that you need to worry about is square roots. Square roots have to be 0 or greater, and denominators can never equal 0. Those are the two things you really have to worry about. Look at 11. If we look at number 11, we get f of x is equal to x squared over x squared plus 7. Now here we have to worry about when this denominator equals 0. So I'm going to come over here and figure out when is that equal to 0. X squared plus 7 equals 0. X squared equals negative 7, and we take the square root of both sides, but we realize, you know what, there's no time that this is never defined. And so what is the domain of this? We like to show it in interval notation, and we show it this way. What's the absolute smallest number? Well, it's negative infinity, and the absolute biggest is infinity. and we show it within the parentheses because we can never reach infinity or negative infinity. Now, if we could reach it and we wanted to include that as part of our answer, we would do square brackets instead. And then we look at example number 12 for the exact same thing. F of x, or we get this expression x over the square root of x minus 5. Now, a couple things are really going on here. Basically, not only does this have to be or can't be 0, but it has to be 0 or bigger. So in other words, we need to have the square root of x minus 5 cannot equal 0, and at the same time, x minus 5 has to be greater than or equal to 0. Well, we can really combine these two different statements into this simple one. X minus 5 has to be greater than 0. Because if it was equal to 0, then we would run into problems there. And then this becomes very simple to solve. Add 5 to both sides, so x has to be greater than 5. And so how do we show that in interval notation? Well, we want it to go to 5 and go forever in the positive direction, so that's infinity. We know infinity cannot be included. It's always a parenthesis. The question is, do we want to include 5 as part of our answer? If it would equal exactly 5, then this would become a 0 and we're in trouble. So we want everything just above 5, but we do not want to include the value of 5.